In this video, I will go over some questions on the review for exam 1 for Mat301. I suggest that you try the question yourself first before watching any part of this video. Okay, so let's begin. We start with the question number 1 that's asking us to find the derivative. Well, they're asking us to consider the following function. It's 2 divided by x minus 3. Okay, so first part, we need to evaluate the function here at 0. If we do so, that just means substitute the value inside the function, which will give us 2 over negative 3 or negative 2/3. The second part is asking us for the limit, and first we're starting with the limit as x approaches 3 of this function. Any limit question begins with the direct substitution. So if you substitute number 3 inside the function, we'll get 2 over 0. Okay, if you recall in class, that tells us that we encounter here the vertical asymptote, and the function will start approaching infinity or negative infinity depending on what side you're looking at. So now by making a little table and choosing the values to the right and to the left of 3, we can see what's going on. Alright, so a 3 does not exist because we're dividing by 0. If you choose number less than 3, for example 2.9, notice the denominator will be negative. So we're taking 2 and dividing by something small. So in this case it's negative 20, but this was just an example to show that the graph is approaching negative infinity. If you pick the number 3.1, then you get 2 divided by a positive 0.1, that gives us positive 20. That implies that we're approaching positive infinity. The closer you get to 3, the larger the numbers will become. Okay, notice that these two are not the same. Okay, so that means the graph is actually approaching 3, the asymptote, from different sides. So from the left side, it's going to negative infinity, and from the right side, it's approaching positive infinity. So that's what you would see visually going on. This is a hyperbola, so it actually has both the horizontal and the vertical asymptotes. Okay, part B, well, part A. Yeah, this is still part A. Sorry about that. It does ask us to find the limit as x approaches 3. So as x approaches 3 from both sides, and because it's different, then we say that the limit does not exist. However, limit as x approaches 3 on each side, so if you approach it from the right side, it does exist. Alright, from the right side, meaning from here, the function is approaching, as you can see here, it's approaching positive infinity. So that does exist. It's infinite though. Okay? Alrighty, next we want to talk about any discontinuities this function have. Alright, so discontinuities. Now we know that when we substituted 3, that's the only troublemaker, right? The domain of that function is x does not equal to 3. If you substitute, it doesn't work. So f of 3 does not exist. That automatically makes the function discontinuous. Is it removable or not? That has to do with the limit. If the limit as x approaches 3 is finite, then we say that it is removable. But it is an asymptote, and in this case, it doesn't even exist. So how are you going to remove an asymptote? It's not possible. You cannot connect the two branches together. So because the limit is not finite, the discontinuity is classified as non-removable. Okay. All right. Let's continue with this function. The next part is asking us to compute the derivative using the definition. Okay. This is somewhat complicated function to do it using the definition. However, it's a good one to practice with. Okay. So let's try it. Limit as delta x approaches 0, f of x plus delta x minus f of x divided by delta x, and the function that we're dealing with is again 2 over x minus 3. Okay? Alright, so this is a definition of the derivative. This is f prime of x. Alrighty, so let's do it. So we start with the limit as delta x approaches 0. Okay? And we're going to take this highlighted part and this, and we're going to substitute that in the function. Alright? So now, let's put that in. So we start off with f of x plus delta x. So we take this right here and we substitute inside the x. Alright? So look what it will become. So it's 2 over, then this highlighted part, okay, gets substituted. So you get x plus delta x, and then you do minus 3. So that's the first part. Okay? Then we're going to subtract the original function, which is 2 over x minus 3. And this whole thing is divided by delta x. So this is pretty advanced one because the expression is somewhat complicated. Substituting 0 inside right now would not help since it will just give you 0 over 0. So we need to get rid of this complex fraction. So what we could do, we can go ahead and find the common denominator. So the common denominator here would be a product of these two denominators. So we have x plus delta x minus 3, that's 1. And then x minus 3 would be the other. Okay? And then we're going to take the first fraction right here and we'll multiply it by that other denominator, while we're going to take this fraction right here and we'll multiply it by the first fraction denominator. Alright, so this is quite complex, so let's see what we get. Here we're going to distribute the 2, so we get 2x minus 6. Well, here, notice there's a minus sign, which is always an issue when you dealing with the difference quotient. It's a subtraction right here, the difference, and being careful about the distribution. Okay, so let's go ahead and let's distribute it. Okay, so we'll distribute negative 2 inside each term that we see. Okay, so we got negative 2x, negative 2 delta x, and then plus 6 because you have two negatives. Dividing, and then we're dividing it by delta x, which is the same thing as multiplying by 1 over delta x. So we can get rid of the double fraction. Okay, now we're still doing the limit. So limit as delta x approaches 0. Alright, so we're not going to do anything to the denominator, so we're just going to copy it. X minus 3, and then we have delta x. Remember, the point of doing difference quotient will tell you that you're doing it correctly is that eventually we'll be able to cancel out delta x, and that will happen if all the terms that do not contain delta x in the numerator will reduce. Now look at this, 2x minus 2x gets reduced, negative 6 and positive 6 gets reduced, and you're left with negative 2 delta x. Okay? So now you see you got this, you got that denominator right there, and then you can go ahead and reduce the delta x. So once you've done so, then you can take the delta x equals to 0 and substitute inside the expression that you see. Okay, so you get negative 2, and here you got x minus 3 multiplied by another x minus 3, which gives us negative 2 over x minus 3, the whole thing, not the whole thing, but the denominator squared. Alrighty, so that's our result. So it was quite complex. You should go over other ones that we have done in class as well as in the quizzes that concern that. The other part of that question asks us to compute the same derivative using the power rule, and for the power rule, this is not too bad of a function to do, okay? So that would be a good example on differentiation. So let's do that using the power rule. Well, actually, it's not a power rule, it should say a quotient rule, since we're dividing a fraction. The power rule does not apply here since you have a division of two things, okay? So let's take a look. So we're differentiating this. So we got the numerator, we have denominator, So then we apply the quotient rule. So let's first write down what the quotient rule is, and then we will do the derivative. So the quotient rule is, once you apply it, it has, so you start off with the fraction. The fraction will have the denominator squared, okay? And the numerator will be, you keep the g multiplied by the derivative of f, minus, then you keep the f and take the derivative of g. Alrighty? So now let's go ahead and do this. So g squared will be the denominator squared. So we're going to take x minus 3, and then you square that, right? The g is x minus 3. F prime is 0. Derivative of 2 is 0. Derivative of a constant is 0. Then minus, you keep the f times the derivative of g will be 1. 0 times anything is 0, so then it nicely simplifies to the same thing that we got using the definition of the derivative. So this is a rule, and this is a definition, and they are corresponding. Okay, so must be correct. Okay, so that was the first question. It has lots of parts, just making sure that you review all the ideas that we have discussed when it comes to a function and the calculus of the function. Alrighty, so next is talking about the limits. Alright, so number 2, with part A, finding the limit as x approaches 4 of the function. If you use the direct substitution, 3x plus 1, you'll get square root of 16 minus 12 plus 1, which is square root of 5. It gives us the answer, so we are happy and we're moving on. Nothing else needs to be done. The second one, you do limit as x approaches 2. You have the ratio of two functions, so you got x squared plus 8x minus 20. And the bottom is x squared minus 4. So if you substitute, you get, so the top is 2 squared, so it's 4 plus 16 minus 20, and the bottom is 4 minus 4. So we get the 0 over 0 form. That tells us that we need to do algebra. Okay, so let's go ahead and do it. Notice when you're substituting 2 inside the expression and you're getting the value, you're getting a 0, it right away signals that x minus that number that you substitute is a factor of both of these expressions. We can say it 100%. The denominator is quite obvious that it is, so here we go. But for the numerator, it's also quite, not too complicated. You can see that that would be 10 in this case. Then that gets this reduced. Then you take the limit as x approaches 2. So you got 12 over 4 for the answer of 3. Okay, so this is a classic question on limits. Alright, part C. Take limit as x approaches, what number it is? -5 of x to the third plus 125 over x plus 5. Again, it's no surprise once you substitute this here, you're getting 0 over 0. So you need to do the algebra. The algebra here is a little bit more complex. So if you use a formula, this becomes the sum of the cubes. And sum of the cubes equals to the sum of the two numbers times the square of the first minus the product of the two numbers plus the square of the second, like that. Now notice that here the formula is that when you have the sum, you first sum up the numbers, but here it will be incomplete trinomial. It will be the square of the first minus the product plus the square of the second, and then this cannot be broken down further. So in our case, we're getting exactly what we need right here. We get x plus 5. Notice this is exactly x minus that number, which is a factor. And then the other part is x squared minus 5x plus 25. That will reduce the denominator. And once you reduce the denominator, you can substitute, I want to substitute, it would be 25 plus 25 plus 25, which is 75. Okay? Alright, alternatively, since minus 5 makes the expression 0, you could have also used x cubed plus 125 and break it down the following way. You can go ahead and write the coefficients of it. So that's a cube, that's a square, that's a linear, that's a constant. And do synthetic division, dividing it by a -5. And that will give you same thing. So that would be 25. This is negative 125 at the remainder of 0. That gives you x squared minus 5x plus 25. And that way, you can write it this way here. And then reduce it the same way. Okay? That has to do with synthetic division. So review that concept if you are unaware of it. Alrighty, so we are on part D. I've seen something like that in class. You've seen most of these. So with part D is the expression involving a root. So you got square root of 4 plus x minus 2 divided by x. Substituting it, not a surprise, again 0 over 0 form. Recall what we do? When dealing with the this expression involving roots, we're multiplying them by the conjugate. So the conjugate of the expression is the same thing, but with the opposite sign. So you add instead of subtracting. And whatever you do in the numerator, you also do in the denominator. Here it's a little harder to see because it's somewhat a complicated expression. You can think of this as multiplying the difference of the squares, which will become the square of one minus the square of the other. Okay, so now what does that mean? It means you take this first term, right here, I'll highlight it, you square it, and then you take the second one and you square it. Well, look, once you square this, the square root will disappear. Once you square the 2, that will become a 4, and then you're just subtracting it. You see? Alright? So that will happen with these two. Because when you multiply the difference of the squares, it becomes the difference. Well, it becomes the difference of the squares. And the denominator will be x times that other thing. 4 plus x plus 2. Do not distribute it because eventually you'll be substituting the numbers in there. Okay, so note with the numerator. 4 minus 4 reduces to 0. Then you got x and an x that will get reduced. And then you're left with the limit as x approaches 0 of 1 over square root of 4 plus x and then plus 2. You see what happened is that we just reduced the force first and then the x, the one that gave us undefined denominator. But then once you substitute 0, you get 1 over square root of 4 plus 2, which will be a quarter. Okay? Alright, two more trigonometric. Oh, there's more. Okay, so trigonometric 1, E. Alright, so E. So we got limit as x approaches 0 of sine of 5x over 4x. We have talked about this several times. Just whenever limit as x approaches 0 of the trigonometric expression, the angle inside the trigonometric function will be close. The sine of an angle will be equal approximately to the value of that angle as x gets close to 0. So we just take it out, cross out the x's, and get the answer. Alright, so we've seen those. F, somewhat harder. You've seen this in class as well. If you substitute 0, you'll get 0 over 0. just like the one above. I forgot to mention that. And then look, the only thing we basically talked about in class when it comes to trigonometric limits is that we have this special limit that equals to 1, and you also have this special limit, which you've seen in class as well, that equal to 0. Notice both of them are divided by x, which matches the angle of the sine and cosine. Here, right here, you have the parts of that expression. So what do? Well, you basically do the same thing in numerator and denominator, so it looks like that. Note, they both have an x in the denominator, here and there. So what we're going to do, we're going to introduce that in our expression. So we'll have 1 minus cosine of x. We're going to take this and divide it by x. And then we're going to take the other one, sine 4x. And you're also going to divide it by x. Dividing both by x, as long as x is not 0, it's approaching 0, will give us the same expression back. But what it allow us to do, it would allow us to take that limit and distribute it to each part separately, to here and to here. And then what do we get? Well, the first one is directly from the formula, from the limit of 1 minus cosine over x, which is 0. On the bottom, we did a similar thing earlier there, and e would be 4. And 0 divided by 4 is 0. Dividing any number, dividing 0 by any number will give us 0 as the result. Okay, so that's the answer for part F. Okay, G. You got the limit as x approaches 2 of 2 plus x over x squared minus 4. If you substitute 2 inside, you get 4 over 0. And once again, just like the earlier question, it is undefined. It's going to be the vertical asymptote. So you need to substitute the number from the left and from the right. And just like we did before, you can confirm that as you approach it from the left side, like a number, something on the left of 2, like 1.5 or 1.9 would be better. The top is positive. The bottom is 1.9 squared is less than 4, so that will be negative. Positive divided by a negative is negative, and we know it's going to infinity since you're dividing it by 0. And on the other side, when you're approaching from the right side, you have a number like 2.1, okay, 2.1. So we have 2.1. 2.1 substituted in the numerator will be 4.1, which is positive, and the denominator will be now higher than 4, will also be positive. So the result will be positive infinity. So here it's positive, here's a negative, it's not the same, so the limit does not exist going from both sides, but each individual limit do exist. One is positive infinity, and the other one is negative infinity. So that is fine. Okay, part H, limit as x approaches -2 from the left side, and we got 2x squared plus x plus 1 divided by x plus 2. So if you substitute -2 inside this expression, okay, you will get 4 times 2 is 8 minus 2 plus 1, so that's a 7, and the bottom is 0. So look at this. Again, we know that it is going to be a vertical asymptote. So the question is it infinity or negative infinity on whatever side? And because we're approaching from the left side, we will get the answer. We just need to know whether it's positive or negative. So what I would do, I'll right away put the answer as infinity, and I need to check the sign. So I need to choose a number to the left of -2. So that would be something like, let's say, -2.1. Make sure you're going the right way. We're going on the left. On the left, the numbers are further negative. negative 2.9, negative 2.1. The denominator will be negative, while the numerator would be, so negative 2.1 squared, it would be, so negative 2.1 squared, that would be positive. That would be about 4. 4 times 2 is 8. Well, why, look, why am I doing this? I know it's going to be too close to 7, so that's not a concern. It's going to be close to 7. Because numerator is going to 7, it's not going to 0, so I don't really need to plug it in there. I know it's going to be 7, close to it, but the denominator is negative. If you take something that's close to 7 and dividing by something small negative, then the result is a negative number. So the answer will be negative infinity here, not the positive. Okay, once again, you see, the numerator is 7. The denominator gets close to 0. That means you're dividing by something small, which results into infinity. The reason it is a negative infinity in this case, because the numbers on the left, like negative 2.1, make the denominator negative. Okay, that's why the answer is negative. While on the right side, it will be positive. Okay. Alrighty, and the last limit question, I, is the limit as x approaches 0 from the right of a natural log function of sine of x. Okay, sine is this. This is the graph of sine. You're approaching it 0 on the right side. As you're approaching the limit as x approaches 0 of sine of function, then the answer is 0. But because it's from the right side, then it is kind of, you see, it's from this side. The values, the outputs are going to be positive, right? That means that you're kind of getting positive results. So this is the same thing as approaching 0 from the right side of a natural log function by itself. Because what happens is that as sine approaching 0, as x approaching 0, sine is also approaching 0. So then we can replace sine of x with just 0, because that's what it's becoming. But it's a positive 0, quote unquote, meaning that it's coming from the right side. And then going to the natural log function that looks like this. The limit as x approaches 0 from the right side goes down. You see how the graph is going this way? Right? So that is negative infinity. Alrighty? Okay, so we'll resume in another video.